Okay, we're going to continue from question number 5. Okay, let's bring the question to the whiteboard, please, and we shall begin. Okay, let's read first as usual. So the equation of a curve. Okay, the equation of a curve is y equals to 2 cos x plus sine 2x. It's the equation of some kind of curve. So find the x coordinates of the stationary points. Stationary with the A means it's the where the dy dx is 0. Okay, stationary points is where the dy dx equals to 0. Coordinates of the stationary points on the curve for which x is between. When they put 0 to pi, it's understood that the units is radians. So that means 0 to 180 degrees, and determine the nature of each of these stationary points. Stationary points, there are 2 types. There's a minimum and a maximum. So we need to determine the nature of this of it. So to show whether it's a minimum or maximum or not, I need to check. You check a second differential, and then minimum means it will be positive when you substitute the value of x from the dy dx. So now this x here, the value of x that is sorry, it's not that notation. Value of x from here, sorry. D square y, if maximum means the second differential will be negative. So just a general idea. So if you must have a general idea what we're going to do first. Okay, now the details for each step. Okay, so stationary point means we straight away just do a dy dx. Let's see what is dy dx here. So differentiate cos is negative sine, so negative to sine x, like that. And then differentiate sine x, sine 2x, sorry. We differentiate sine becomes cos, so we just copy cos 2x like that, because differentiate sine is cos. And then inside, due to the 2x, you differentiate the 2x chain rule, this becomes 2 multiply in front. Okay, so this is what we want to make it as 0. Okay, and we're going to solve to find the stationary points accordingly. Okay, how do we do that? To do that, okay, so we need to use a double angle formula, which is, okay, let's divide first. Divide throughout by just 2. So it becomes cos 2x is equal to 0. So we replace this cos 2x has 3 derivations, but since this is a sine x on the left, so I would use that version. That means 1 minus 2 sine square x. Okay, 1 minus 2 sine square x. And this is equal to 0. That's cos 2x on that particular part. So now I can see that it's going to be, let's rewrite it first. 2 sine square x, when you bring the other side, okay, plus sine x. And then the plus 1 you bring there becomes minus 1. So it becomes 0 when you minus 1 like that. Plus sine x minus 1. And naturally it's a quadratic now because we have the same unified variable, which is the sine. So sine x, so let m equals to sine x, just for simplicity's sake. So it looks easier. So it looks like 2m squared plus m minus 1 equals to 0. Then we need to factorize 2m. So going to be a plus and minus, right? So to determine that, we look at the coefficient middle is a plus. So plus 1 here, minus 1 and an m. So always put your mind or multiply and check and see, or you can use a calculator at this level, okay? So either one, so you'll get this. So m equals to 1 over 2, or m equals to negative 1. Either one, m equals to everything. So what is m? M is, so sine x equals to half, or sine x equals to negative 1. So there are 2 possibilities here. So perhaps I'm going to just copy this at the top so that we can do a split on a branch like that. So sine x equals to half, or sine x equals to negative 1. So the first thing when we see something like this, we want to find the acute. These are special values. So the acute is quite straightforward. That means the acute part, acute of x would be, on this is 30 degrees, or the acute of x here would be, think of 1, just ignore the negative sign. Sine 90 is 1. So that's how we do acute. We ignore the negative sign for the acute part. And then we draw the 2 possible branches. Okay. What are these two possible branches? What am I talking about? So I'm just going to put that here. So put an or here, so it's a bit more clear to see. So the first one looks something like this. So we draw the quadrant as usual. So here we have the quadrant. Okay, let's think and see carefully. Sin x is half. Where's the half? Aha. So I'm going to draw, let's say, a pink line to follow that. Just thinking color. Okay, sin x is positive. Oh yeah, forgot to write something. Sorry, just one small thing. CAST. The cosine, all positive, all the kind of thing. So CAST like that. And then on the left one, sin x is half. So sine is positive. So when sine is positive, it means we put in the all here, all is positive, or sine alone is positive. That's the meaning of the S. So I'll do the negative when one go in parallel, so it'll be easy to see. So sine x is -1 on the right corner here. So the cos here is only cos is positive, meaning sine is negative. And then similarly here, only tangent is positive, that means sine is negative. You can read it like that. Sometimes I repeat these things so that you can get more, or you can get more familiarized with the concept. Familiarize yourself with these things. Okay, now we continue. So let's mark the acute angle. So in each of these, the acute angle is always towards the x-axis. So it's a 30 degrees here and here. Likewise, here is 30 degrees here and here. Oh, sorry. The other one, the acute is 90. How silly of me. I went and drew this. So if we mark the 90, see how silly of me. That's not paying attention on that. Doing it very naturally. So 90 means negative. There's only one line here because both ways 90 will force it along this line, right? So it's okay. Just now you saw it like that. It moved here. Or you saw it like in between, in this quadrant, it moved here. So since both are moving to the same point, there's only one value here. That's the reason. So at least you learn a new thing in that, what do we say, aspect. Either this way or this way, also you mark the 90. It doesn't matter. Both ways is correct in this case. Okay, now what we need to do is, let's think and see. Okay, so what we need to do is, so we need to do like this. So from here to here, the quadrant thingy. So this is 0 degrees. So I'm reading it anti-clockwise. That's a positive direction. 180, 270, and one full round is 360. So just what we do in this. So good to label that now in order. So what is the value to the pink lines? Okay, let's take a closer look, please. So the first one tells me that x could be, now the value of x is determined 30 degrees, or x could be from, sorry, let me use a different color just to contrast these lines. From here to here, which is 180 minus that 30 extra. So you can see that. So in other words, we have two values of x here. X is 30 degrees, or x is 150 degrees. Okay, actually it's not really, they asked the coordinates, right? X coordinates only, yeah? So also take note of that. Only the X coordinates, put a box there. So I'm just trying to follow the requirement in the book. Okay, let's take on the paper, sorry. From here to here, all the way to here. So it's obvious that it's a bit easier. It's just X is 270 degrees. So the X coordinates, that means we have 3 of this, but actually I did an extra. This one we have to reject. I just wanted to do it so you'll know. And then there's such a thing, but this we reject because this one is X is out of the range. X is bigger than 180 degrees or bigger than pi radians. Remember this? Put in the green box now. So this part reject, this branch. So that means we just need to determine for this two. Okay, so since that is rejected, so I'm just going to erase that part now. Okay, all this part gone now. Okay, this one only this. But I mean, good to learn how to do it in case the range was greater. Let's say the range was from X to 0 to 360 degrees. Normally a full round, they call it a 1 revolution. We would have included that. Okay, that's the meaning. So we know this thing. So now X is either 30 degrees or 150 degrees. So we want to determine the nature of each of these stationary points. These are the stationary points. Okay, but they're not asking for the y coordinates, so I'm not doing that part. Let's take note carefully. So the nature for when x equal to this, so we need to do a second differential. So from the dy dx, which I'm going to box now, this part from here to here, look at the dy dx here. So I'm just going to copy it here, up here. Okay, dy dx equals to -2 sine x plus 2 cos 2x, taking it from the earlier step. We do a second differential. Just continue the differentiation, please. So dy square dx square. So when you differentiate this, yeah, sine x when you differentiate is cos x. So we can just put negative 2 cos x. Here you differentiate, becomes cos is negative sine. So there's a negative 2, then differentiate inside 2 times 2, 4. So I'm just doing it in one go. Sine 2x, okay? Sine 2x, negative of that, multiply the differentiate inside. That's called the chain rule. Okay, now we have this expression for the second differential. So we want to substitute for each of these separately. If x equals to 30 degrees, or in the other one, if x equals to 150 degrees, what happens? So I personally prefer to write it in degrees, more used to it than taking radians, though they put that in radians. So the second differential evaluated here, just substitute the value as 30 degrees minus 4 sine 2 times 30, 60 degrees, like that. So I'm just putting in this substitution. Or on this side, let's calculate that, please. On this side will be d square y dx square due to space, this thing I write like this. So minus 2 cos of 150 minus 4 sine of 150 times 2, 300 degrees. So all this you can just use calculator. This is special values can be computed. So sometimes it doesn't matter. So let's put in the calculator, please. For the left branch, negative cos 30 minus 4 sine 60. So my calculator tells me that this is about negative 4.33. And on the right hand side, that means this is less than 0, negative. Okay, let's look at the other side at the same time, please. So the second differential would be negative 2 cos of 150 minus 4 sine of sine of how much? 300. So it becomes 5 point, let's say 5.2. 5.2, and this is a positive. Oh, this is negative and this part is positive, huh? Okay, so this is negative and that part is positive, second differential. The second differential negative means, this means that this is a maximum coordinate. So it's a maximum point. So that means x equal to 30 degree represents a maximum point. And then local maximum. So positive means, remember the starting there, I wrote that. D square dx is for x equal to 150 degrees in particular. When the second differential is positive, that means this is a minimum point. So that's it. Since they only ask the x coordinates and the nature of the stationary point, that's all we have it at that point. That's it. Yeah. Thank you.